Okay, so I think we can get started. Welcome to the first experiment of Show Us Your Projects. This is a session where everyone is welcome to show their projects. Oh, but wait, who's showing?
Natalie has jumped the gun here, Natalie.
You rushed the stage.
So it's, yeah, we have a queue. Natalie, you're there. I'll be calling you guys by name, and I'll say who is going to present now and who is going to present afterwards. So the person who goes second can prepare their project already. I'm going to be very strict with timing. We're going to have 3 minutes, and I'm going to use Alonso's sense of time. When this sun goes, when this sun runs out, you'll have to shut up. Otherwise, I'll bring out my turtle ocarina and very annoyingly make you shut up.
Natalie, you've done it again.
So we're going to start off with Simon Walters, and afterwards it's going to be Yatka. Is Yatka here? Otherwise,
yeah, I'm here.
Yeah, okay, perfect. So Simon, and after Simon is going to be Yatka. Stage is yours. Simon, let me.
Thank you very much. I'm sharing my screen. Please tell me when you can start seeing my sharing.
Yes, we're seeing it.
Great. Right, so this is a project about the Mayflower MAS 400. I did put a link in Twitter and on the forums to tell people what it is, and I've only got 3 minutes, so I'm not going to. So basically, it's an artificial intelligence boat that's designed to go across to from England across to America. And the best thing is that it's sending out a data feed over satellite using the MQTT protocol. I'm not going to go into that. I'll put links to all this stuff afterwards. So basically, luckily, Xavier P has written a snap library. Where is it? Of course, he can't find it now across the top. Here I am. Written a snap library that's available. So we can use this protocol in Snap to get hold of data from MQTT sources. So there's all the blocks there and everything. Anyway, just getting back to my project. Going back over here. There we go. So I'm using this data and feeding it into a Snap project. The basic thing is you connect up to a data feed, which is this one here, mqtmas400.com. You use the block that says connect to that broker and it works. I'll press my green button here and it resets. There we go, MQTT connected. Now, luckily, a few days ago, the people decided to put a data replay of this journey. And let me give you a short story here. The journey failed. It only made it out about as far as here, and then it broke down. And they turned it around and tried to head it back home. And eventually, it was just adrift in the sea, and they had to send a boat out to get it. But luckily, they're supplying a replay of the data feed. So if you look at the top there, it says date June 17. Anyway, so here's my project, and I made it that you can have buttons to zoom in and out. You can center the map on the Mayflower, and you can change the map style. So there's topographic, satellite, which shows it just about made it to the edge of the continental shelf. And I was hoping to be able to zoom out and follow it all the way across the Atlantic, but it never made it, and it's returned to port. But hopefully, when it tries again, we'll be able to follow it and track it and use it. But like I say, this is just I just love MQTT. You can use it in any programming language. You can use it on very constrained devices that cost $2. It's just fantastic. And the fact that there's a library available in Scratch is just brilliant. And, you know, that's what I do. Other things on the map I should show you while you're here. You can move the map around. Things like that. Have a bit of a look at the code. I don't think there's much, well, there's all sorts to see in the code. And this is the basic thing here, that once you've made a connection with MQTT, every time a new message comes along from the boat, it updates and I make it send out a broadcast. Thank you very much.
Thank you, Simon. That was awesome. Okay, Edgar, are you ready?
Yeah, wait, let me share my screen. No, I want to share the whole desktop. Okie dokie. Yeah, I guess I'm ready.
There we go.
So this is the project that I wanted to share. One of my flatmates, Yule, she studies special needs pedagogy, and since university took place in our living room last year and we watched every lecture on the projector, I tried to build her a sign language dictionary where you could learn German sign language. So this is how the project works. I can record signs. Wait, let me start it first. By using Snap's video feature. So now I'm asked which word I want to add. So I'm going to add a German word. Let's try Blume, which is flower. And then I'm asked which type of word this is. It's a noun, which is substantive in German. And then I can record the sign by pressing the space key. And now I have the sign in my new dictionary. So let's show the dictionary. This only has one sign right now, which is Blume, and we can also replay that. And I also use Snap Stretch Block to make the file a little smaller. And yeah, so we can add more signs. Here's the version that we have been using, and I added 2 more features. So for example, you can look for a sign by pressing the space key. It asks which word you want. Now I have to check what we have. So for example, I could look for let's try Heidelberg. And I could just look up words like in a dictionary, or I could even test myself and let it give out a random word if I press the A key. Oh, yet I think that's what. Let's try that. Das. So I'm not sure whether that was true. Anyways, let's try another one. Maybe one that I know better. That's mama, like mom. So let's try that. Yay, so this was right. That's my project. I hope you can use it a lot. And unfortunately, I can't join her lecture next year anymore because university will be back in the actual university building, but maybe we can use her project for future things. Thanks.
Okay, you still have some. You still had some seconds left. Really nice. I forgot to announce the following one.
Oh, sorry.
So I tried to do that over the chat. Matthias Giger, are you ready to show yours?
I'm just going to share my screen.
Okay, and after you is going to be Ridaya if they are ready.
Can you see my screen now?
Yep.
Yes.
Let me start the timer.
Okay. You should see the paint editor, and I'm going to tell you a small story about a king. Here it is. And of course, he has got a lot of people to rule, but after some time you get 2 kings. And now the people don't know which king to follow. So we use a technique where we use a bisector to separate the kingdoms, and it's simple. But once we have an additional king, maybe here, we have to put another dissector and so on. And if you add one here, maybe it gets a bit more complicated because you can make the border between these 2. But of course, this border is not correct anymore. You have to adjust it. And basically what you get is a Voronoi diagram this way. And that's what I'm going to show you now. So we start with seeding the place. Here you should see the kingdoms now. There are a bit more than 3 or 4. And I don't want just the borders, but I want to show proximity to the next king. So that one we can do now. Let me show the script here. So if I press here, it will calculate for each spot how close it is to the next kingdom. You can see the kingdoms in the colors, and the closer you are to the king, the brighter the color. How does this work? Of course, I can't draw by sectors, but what I do is I make a list of all the kings. That's in this part of the code. And then you look how big is the distance to each king, you sort that list, and then you color the point according to the color of the next king and to the distance. Of course, you can also play a bit with this and make it so that the closer you are to the king, the darker the color gets. So you get some kind of cell-like structure, whereas in the first one we had more like an atom-like structure. And then you can also do some other tricks like multiplying the distance, use a modulus on it, and then you get stuff like this. It takes a while to calculate it. So if you have a really big screen and fine-grained pixels, then it can take up to an hour, but you get all kind of interesting pictures. And the last one I've done works a bit differently. Here, you look from every point to the direction of the king, and the people march towards the king, and that's what you get.
I'm sorry, this was really nice, and it reminds me of Berlin noise for some reason. Okay, up next is Russell, and afterwards Xavier, if you're ready.
Okay, so everyone can see my screen?
Oh, yeah, sorry, 1 second. Let me start the timer. Okay, go.
Okay, so what I have here is an implementation of the ChaCha cipher. So basically, it's actually a usable cipher. This implementation isn't because I don't even know if the random numbers are generated, and it's just probably got some bugs in it somewhere. But in theory, ChaCha is a competitor to AES. So here you can use the green flag, generate a key, which I'm just going to call example key. The right arrow, I can make a message. And then it takes surprisingly long because I had to do all the bitwise operations manually here, and it generates something like that. Now that has the message for most of it. The last some of it, I don't actually know, but some of it is number used once, which is that part is first. It's just so that even if you encrypt two things that are the same message, they won't come out to be exactly the same, which is important. So then if I press the left arrow, paste the encrypted message there, and press enter, then it decrypts it. This message, which is exactly what I typed in the first place. And obviously, if I put the wrong key there, and then I press the left arrow and paste that message, then it gets something that's completely wrong. But I can put the key back, and then it will decrypt it correctly because the key is correct. So that's 2 minutes. So it's not like RSA that can just generate. It's not public-private key. It's completely symmetrical. In fact, as you can see, except for the various encodings, the encryption function and decryption are actually the same block. But it's just in one case it's encoded as hexadecimal, and in one case it's just encoded directly in ASCII, which means the one will be a bit over twice as long. Also, the nonce is generated randomly when encrypting and is stored as part of the encrypted message, where it's not stored in the decrypted message. Yeah, I think that's everything.
Really nice. Is there any part of computer science you haven't mastered yet after 3D and encryption. Okay, so next up is Xavier P, for whom I think we're not going to need the timer because he's prepared the video.
Okay, I share the screen. Okay, do you see the screen? Yeah?
Yep.
Okay. Well, I'm going to show you, this is a remote control based on a low-cost module, ESP8266, that connects via Wi-Fi. And then there are two small breadboards. And here we have a gyroscope. This is an MPU 6050, a very low-cost gyroscope. And also here it is an LDR, but we don't use now in this demo. And this is connected to a power bank that I can grip here. And then here is the code. It's a very small code. I can show this sensor, and then there is another device. This is an actuator. This actuator uses an ESP, is the same chip, and here is a relay. Okay, so I connect to the broker using the MQTT for Snap library that Simon Walters mentioned before. And here it is the code of sensor. So if I start the, all right, zoom. Okay, and here, so this module is programmed with the Arduino environment, and each 2 times a second, each half a second sends the position and the angle of the board. So here I can control. Okay, this is the first demo, no? And the second one is control an actuator. When using this device as an actuator, I can send him a message publishing. Here is the time the light must be on. And here I can show. Okay, and have to wait. It connects to the broker. Oh, it is not, that's not correct. Why? Yes. Okay. Oh, sorry. Is yes, I can send a message, and here I can send message in a loop. Okay, that's all.
Okay. Nice. I'm not being forced to use my ocarina. Thank you for keeping it on time, everyone. The only problem is we're going to finish in like 10 minutes if we keep up with this pace. So if anyone else wants to show the project and they haven't said so in the forums, you are absolutely welcome to say so in the chat and just hop on stage. So next up is Hridaya, and I'm sorry for mispronouncing your name probably. Is Richard Millwood here today? I don't think so. So next up is going to be Brian Broll. Will you be ready, Brian? No? Okay, so what about Gordon Stein?
Yes, I'm ready.
Okay, so you go next. Okay, let me start the timer and you go.
So this is a mobile app, and it is made by Phone IoT. Could you see my video?
Yes.
Yep. So that's we control it using the mobile, and it uses an accelerometer from the mobile. Yep, so that's the game, and you have to go up to the flag, and these are gliding holes, and you just fall in a hole and you die. And also it has a timer that can be seen in the app. So yep, that's it.
That was great. Now we have to wait for the timer to run off because unfortunately it's the opposite of digital. So we have to wait for this sand to go down. I'm actually going to turn it
There you go.
the other way around. So we have to wait less. So next up should be Gordon Stein. Is Brian Broll around? I think he was there before, but he's now gone. Okay, so is Richard Millwood here? I don't think so. Is Natalie here?
Yes, I am.
Okay, so you're next after Gordon.
Okay.
Now, we also have, okay, I'll say the lineup. It's Gordon now, Natalie afterwards. Then we have Dan Garcia. Then we have Brian Harvey. Then we have Jens. Unless Brian Broll and Richard Millwood show up before that. And after all this, we have Ogechi and Matthias again, if there is time, which I think there will be.
You need 2 timers in the future. Have one ready.
Yeah, it's hard to find 3-minute timers. I had a 10-minute one and a 1-minute one.
It's also okay to have a 2-second break in between things.
Yeah. Okay, so Gordon, can you share your screen?
Sure. Really, we should have a timer made in Snap that you could
Yeah,
use.
yeah.
That'd be fitting. All right. So I just want to show a quick little demo I've made here. So if you saw the lightning talks, you would have heard me mention a robotic simulation we've been working on. If you stick around for the NetsBlocks keynote, you'll actually get to see that version of things. That version is made in Unity. It runs outside of Snap. And we've kind of had a bit of a pain of students have to switch back and forth, and they can't see their code easily and see what their robot's doing if they want everything full screen. So I've been working on a way to actually integrate that directly into our NetsBlocks interface here. So here I have the stage replaced with this. It's actually a 3D environment that I can drive this robot around in. So if I move the camera around, you can see it's actually here in 3D. So now I can drive my robot. Now, this is something I've put together for SnapCon 2021. So I've been working at it for all of the weekend, really. It came along quickly because I was reusing some old code. So still a lot of quirks and a lot of features it would need before it's really usable. But I'm hoping we can make this something that's available to people as a lightweight version of our main project, and also possibly generalizing it to 3D objects in Snap in general. Because with NetsBlocks, we could have kids making, they could make a 3D multiplayer game, and I think that would be a really incredible thing to see done by novice programmers putting blocks together. So yeah, sorry, quick demo, but yeah, don't have to get ocarinaed. So thanks for listening.
Don't fear the ocarina. Nice. Okay, so we have to wait again. Let me go again through the list of people who maybe joined. Is Richard Millwood here now? He's not. Is Brian Broll here now? He's not. Okay, so next up is Natalie. And after that is going to be Dan Garcia. Are you going to be ready, Dan?
I am.
Yep, I'm ready.
Okay, we have to wait for the
I
sounds
learned
to
at
go
some
down.
point that if you take the
I
spin it around in your hand, it actually goes
Really?
much faster.
Like-
Yeah, it's yeah, but it's neat. It actually, but you have to kind of go all the way around like this. The bigger it is, it just increased gravity, then it actually works much faster.
You need one of those things that spins the astronauts around.
Yeah.
You're right. Okay, Nathalie, can you share your screen?
Yes. Okay.
Just a second.
You see my screen?
Yeah, okay, there we go.
Okay, so I want to show very quickly my V project about letting you see growing plants. So here is the first example where you can draw a particular path you already had. Okay, and then if you apply the green here, you can see different flower growing. And I just want to show you some flowers I did and a slideshow about it. Here, so you can, when I receive past slideshow, there are all the passes I put in a list which are going to be grown. So it's very visual. So you just have to draw some flowers on the costume, and the costume are chosen randomly at each step, at each flower. And then the path is tucked in a list, and the path is taken back and the flower is drawn. So take it as a recreation. So I invite you to take the project and to make it own and to change the rules of system growing plants and to draw your flowers. So you can draw your random plants. It's okay.
Right on time, Nathalie. I love this variation of V that stops when it touches the stage.
Okay.
Really nice. Okay, next up is Dan Garcia, and after that is going to be Brian Broll. So let me switch my cameras. And Alonso says, go.
Thank you so much, everybody. Good to see you all. So we're trying to teach a middle school curriculum, and we want to, inculcate them with the wonders and beauties and joys of functional programming. So 2 and 3 is like a function. Has an input as an input, and there's an output, and that output is 5, and you can take that output and stuff it into another box and do that. And one of the fun exercises we've ever done, and I don't know how many of your teachers have used this, it's called marching orders. It's a CS Unplugged activity where you sit back to back, and I have a picture, and you have a blank picture. You have a blank piece of paper, and I'm trying to describe to you what's on my picture, and you're supposed to do that. But it's a very command-like thing. So we were thinking, could we have pictures be a return value? Well, no, pictures are things that you do. And I said, well, that's a nice challenge. Can I have pictures be a return value? So line, rather than line being 99, maybe even 999 people out of 1,000, when they think of a line block that draws a line, it's something that does something. It's a command shape block. But this is a reporter, and it reports, if I click on it, a line. Well, I don't want to show you because I'm kind of giving away what it really is, but it's a line. It's a picture. So this is a picture. This draws a picture. If I drag it into render, it's going to actually render that picture. So remember, this is returning a picture. Input is a number, output is a picture. And that picture, when sent to render, actually has some side effect and draws that. Here's an arc. So this returns, click it, it's going to do it'll show you something ugly, ugly for kids. But when I pass it into render, it returns a picture and renders a picture. I added this thing, arc changes the size of it, the arc of the radius, and this too changes what the theta is and what this is 0 to 1. So if I do 0 to 0.5, it'll actually draw kind of a top happy circle. Circle, as you can imagine, is simply just a call to arc with 0 to 1. So if I render the circle, it draws the whole circle. And now you're saying, well, Dan, you need to have something that puts the pictures together, right? Picture, picture, picker, input. How do I combine the pictures? That's what together is. Together takes the input of as many pictures as you want. Picture, picture, here's another third picture, and it outputs another picture. In which, when I render this, you get these two lines together, the line and the circle together. Well, that's kind of nice. One of the things you also need is affine transformations. I need to be able to move these pictures. So here's the same line, but now I'm going to center this at these two values. This center takes a picture and two coordinates where to center it, and will then move it, bloop, around. I also need the other affine transformation of scaling. Takes a picture, outputs a picture, and scales it by 2. Boop, okay? Now that I've got this, I can try to let the students have some fun. Face, what does face take? Of size for the overall picture of the outside, the overall size of the outside face, and then a picture, a picture, a picture, and a picture. Left eye, right eye, nose, and arc. What does face look like? Ladies and gentlemen, it's just together of center these pictures at different places. So what does that? I thought I had 5 minutes, I forgot. And you can do a recursive face. That was it.
Oh, wow.
I was setting my timer for 5 minutes, and that's the recursive face. That's the beautiful thing. All right, thank you.
And you're the fastest speaker around. So that goes to show. Okay, so after Brian Broll, we have Brian Harvey, if he's ready. Are you ready, Brian Harvey?
Oh, yeah, sorry. Oh, wait. Is that which Brian? I'm sorry, I was thrown off.
Yeah, so you're up next, ready. But afterwards, okay, Brian Harvey's ready. Okay, perfect. So Brian Broll, you're...
All right, so...
sorry, just a second.
No problem.
And there we go.
All right, so I'm just going to show this little project that I made a little while ago. That's just kind of a fun little exploration into imitation learning using case-based reasoning. So basically, when the game starts, the goal is you're this monkey and you're trying to catch these bananas. And you can switch and you can toggle back and forth. Ooh, one second, I accidentally cleared my address bar instead. I got a little focus. Oh yeah, sorry, I forgot I have to read the intro. Anyway, so there are a few different fortunes here. Yes, there we go. Now it starts falling in and I start controlling the monkey, moving right and left to try to catch these bananas. And then at any point, I can always just hit spacebar. And now the AI takes over and shows you the most similar case that it's using to reason about what action to take. So I probably should switch back and get control again so I can show it some more demonstrations. Now I can toggle back and you can see that it looks a lot like that grayed out case. And now it's oscillating between these other two similar cases. So you get this kind of in the spirit of interpretable machine learning. You give it a set of demonstrations, it finds the most similar one, and then it overlays it with the the actual case that's justifying its current decision. Hopefully this makes sense. I maybe wasn't the most polished start, but I think it's kind of a fun little way to think about this. And it's kind of funny following Dan's talk, just because we do have things here like a block for rendering the case. So it's it's not quite as functional where we're composing these shapes, in a sort of iterative way, but we do have this single block that takes care of all the side effects. Anyway, so I think that's about it. I don't know if people have any other questions or things like that. And I'll just, if people are interested, I can share the link. Otherwise, I'll just turn it back over to Bernat.
Really nice. Reminds me of the, especially because of the banana and the monkey, of the AI example that we've had. Is the AI
with the jumping?
Yeah, exactly.
Yeah. So the one thing that's interesting here, I guess, on some of these fronts is when you start talking about case-based reasoning, we can start talking about what would happen if there was a bad example in here, which I can just show quick. If I take control back over and just run away from the bananas for a little bit, just kind of add some noise here. Now you can see it'll get a little bit thrown off and oftentimes stop then because it'll sometimes oscillate between things because it's not sure which example is the best. So we start muddying up the expert demonstrations with some bad ones, and and as you might expect, it doesn't behave like an expert anymore. Anyway, then now I'll turn it over to Bernat again.
Okay, and with about 5 grains of sand left, we're Brian Harvey's next, and is Jens ready? After Brian?
Sure.
Okay, so let me.
Here we are. Okay. Thank you. Okay, so this is very much a work in progress that I'm showing, not really done at all, but let me look at this block. Oops, no, not delete block definition, stupid computer. Okay, this is a block called make ordinals. Now you call it with a list of names of ordinal numbers. And the idea is I want to make a block where first means item 1 of, second means item 2 of, and so on. So this is just a for loop that says define this name to take a list as a parameter. This is not my block. This is Dardoro's block originally. But I used it to make ordinals. It's the define that says. And so if I actually run this, you can watch in the palette these blocks come into being. And if I look inside one of these blocks, this is what the block looks like. So this is a very, very, very primitive example of a facility called macros, which I'm working on. The thing I'm hung up on right now is well, actually, let me bring this back. I should not have closed that off. The part of this that's ugly is the actual constructing of a report block with an item block inside that with a variable I inside that. And there's this wonderful thing called quasi-quotation, stolen from Scheme, that lets me do this. This backquote character is just like quoting something, except it allows bits of it to be computed. So if I run this and I pull this down a little bit, the 3 + 4 is quoted, but the comma 3 + 4 is computed and stuck in there. And then there are actually two ways of doing unquotation. Regular unquote, which is a comma, takes this whole list and makes it one item of the result, whereas unquote puts the items of the list in. So this is what I'm working on right now, and I hope to have something better to show in a bit. That's it. Thank you.
Sorry, Brian. Alonso is ruthless. Okay, so next up is Jens, and afterwards we have Ogechi. Are you going to be ready, Ogechi? Okay, let me show my other camera, and there we go.
I was on mute. Okay. Hi, everybody. I just have a very little project I want to show you. You might have seen it on Twitter. I discovered it on Twitter when I watched somebody else show the principle behind it. This is about a Japanese craft, kind of embroidery that is stitching is called, I guess, sashiko. It's kind of like grains of rice. And there is a particular kind of Japanese sashiko that is called hitomesashi, and that is where you have single dotted lines, kind of you stitch underneath and above the cloth in vertical lines, and then you turn the whole thing orthogonal. And so basically, it reminded me of one of the demos that Dan always gives about a dashed line. So here's a kind of a little block I made that draws dashes. And of course, it's recursive. So you draw a dashed line, and you can kind of say kind of the length of the whole line. And this is just the recursive implementation. And you kind of tell it whether you want to start with the line, like with the dash, or with a space, kind of like with the thread above the cloth or underneath the cloth. And then, you know, this is the only choice. Like, do you start with a dash or without one? And so you can enter a little pattern of ones and zeros, for example, kind of 1, 1, 0. And the next thing the script does is it interprets this and turns this into trues and false. And then it just draws the lines, turns the whole thing orthogonal, and draws them again. And this makes funny patterns, actually. So here's kind of always one pattern that starts with a space and one that starts with a line, and kind of we get this pattern. It just always repeats, and then do the whole thing kind of in the orthogonal direction, and we get this nice pattern. And this is something that I thought was kind of beautiful, especially since we can now play with different patterns. Like if I just enter a 1, this is what I get, just a bunch of squares. If I just enter 1, 0, I kind of get something like this. If I do 1, 1, 0, 0, 1, 0, I kind of get a very complicated shape. And when I discovered this, I really spent like almost a day experimenting with different sequences of 1s and 0s, and I finally found an activity for binary numbers that isn't just totally awful to do with kids. Yeah, love this project. Thank you.
That was really nice, Jens. And yeah, it's about the only case of binary numbers that I've ever enjoyed. Okay, so next up is Ogechi. I'm sorry if I'm mispronouncing your name. Afterwards, afterwards is Matthias again. And unless someone else wants to show their project, please, if you do want to show your project, write in the chat. We still have time. And otherwise, I will just show a project. So let me share my other video again. And okay.
Okay. All right. Hello, everyone. This is an updated project. This is a project that we did last year. We showed something like this, like working on spirals and making a mug out of those spirals. For some reason this year, COVID had got to schools and we didn't do much. So we took this project to the next level. We happened to have a family member that wanted, that was having a wedding sometime in April time. And we happened to become the ones to provide the souvenirs. And we made those mugs as souvenirs. I hope everyone can see the screen. Can you see the screen?
Yes.
Okay, so this is the souvenir. The designs that I made with the spirals, and I hope I can go for that. This is the souvenir cups that we made for the wedding, and these are the wedding celebrants. It was very, very entertaining, and I could show you the cups. I have them here. I don't know if you can see them very well. These are like two of the souvenirs that I got, and I kept it. It has the names of the wedding couple on it, and then beside is the spiral designs. And to tell you the truth, the cups went so fast that we even were shocked. We didn't have enough. By the time we shared it, the people were looking for the cups. So just wanted to let everybody know that it's a wonderful thing that happened. That's the wedding, that's the mugs, that's the souvenirs. And I don't know if I still have more minutes. I could show you the spirals, but this was the spiral I showed last year. And
yeah, you have like 1 minute.
Okay, let me see if I can get to. So this is can you see the stage?
Nope.
Nope. Oh, right.
I think you'd have to unshare and share again. Because
Okay.
you're just sharing the Word window now.
Sharing and then share. Okay. So here is the codes for that spiral. This is how we made the spiral. Just something very simple, and you can imagine how this went. How I did this was just placing the sprite in different positions. We also tried automating it today. Ugochukwu and I tried automating it today, and we got this. Okay. So we tried automating it, but it was done manually. The cups were done manually. So this is the level of the updated project that we have. So it has gone out, and we're now using it as souvenirs. And you can imagine where it can go further. I don't know. So thank you. That's my presentation.
Really nice. As Yadga was saying, we should have everyone make their wedding presents with Snap.
Yeah.
Okay, so next up is Matthias. Again, if you want to show a project, please drop your name in the chat. Otherwise, I'll be the last one.
Okay, can you see my screen?
Yeah, let me start, Alonso. Let's go.
So this is part of a course I wrote about CO2 and what it means for people and the environment. And this is basically the intro, where you have a simulation. Let me run it. So you have some air particles, and then the girl is breathing out CO2. And down here you have a sensor. And if you go and move towards the particles and it touches, it measures the CO2 concentration. So basically it's the beginning of the course, and then the students, they actually work with a CO2 sensor based on a microbead or an other food clue. Then we have here an animation how the sensor works. So it's the same principle. You can see that here you've got a lamp which has infrared rays, and then here the sensor. And what happens, the infrared moves through this space, and when it meets a CO2 particle, it gets blocked. So if there's a lot of CO2, you get less electricity here on this sensor. So this is just a visualization. And then in the next step, you have here an animation which shows what happens in the atmosphere. So you've got the yellow light particles which go to the ground and then turn into infrared rays. And then when they touch a CO2 particle, they get reflected. And what the program basically does, it just counts the number of these infrared particles. And after 1 minute roughly, it gives you an overview of what happened and the average temperature. So as you can see here, you can change and adjust all this. And then the last step we do is going from the simulations towards data science. And here you have the CO2 concentration over the last 800,000 years. That's a graphic library I wrote, but I've decided that now I use Eckert's because his one is better and looks much nicer. Let's go back here. Maybe it will stop within the time so that you can see what the measurements are. Then the students can share all these measurements. We put them together in a table and we can compare not only the different parameters, but we can also compare how the program is affected by the speed of different computers. So you go into a deeper discussion about simulations and how well they actually work. So that's an insight into this CO2 course.
Right on the spot. Really cool project too. Okay, so unless there's anyone who wants to show their project in the last minute, I'm going to show mine. It's going to be, someone will have to play the ocarina for me. Let me share my screen.
I'm ready.
Perfect, thank you. Okay, so you should be seeing, wait, you. So there we go. So this all started when one day I started thinking about how come not everyone is named Smith or Jones? How come that after so many generations we still have different surnames, if surnames are inherited and only one survives? So I tried to simulate that, and I made this list of random. This project makes a list of 1,000 random surnames that I'm making up, and then it evolves them. It makes it breeds people, and it only saves one of their surnames. And you can see with time, they actually start getting, some of the surnames start disappearing. Now almost everyone is called either Bifa or Hai or Goyi. And in this case, we're simulating by using this probability of having kids. It's each couple either has 0, 0, 1, 1, 2, 2, 2, 2, 3, 4, or 5 kids. So this is the distribution of possible kids that a couple will have. And you can see that this is the population, the number of people alive. And this is the number of surnames, and it follows this logarithmic curve. And I thought maybe it's because of the distribution, but the truth is it doesn't really matter what distribution you use. After a while, you always end up with the same curve. It doesn't really matter. So I was really surprised, even if you just allow 1 kid or 2 kids per couple, so the population stays constant. I think this is going to run for much longer, but you'll have to believe me on this one. The curve stays logarithmic, so it's really surprising that we are not all named the same. And I think it's because there are so many people on Earth, and surnames get modified with time and language changes and even typos and so on. And since we still have like 1 minute, here's another simulation of the same thing, where these are different surnames and people are breathing, and some surnames are surviving and some are dying. And you can see the ones that are dying in real time, and you can see where they're going and where they come from. Thank you, Dan. You're much more gentle than I was. Okay, so this marks the end of this session, but I didn't want to finish without showing you how to publish your project into the SnapCon collection. Please, everyone that's shown a project today, if you want to, if you're comfortable with it, publish it into the SnapCon collection. Let me show you how to do that. So let me share my screen now again. I will hide this thing once again. So I want to share, say, this project, the Surname Survival 3 project. So I'm going to click on the cloud and open this project in the community site. That's one way to get to the community site from Snap. Otherwise, you could go to My Projects under your user menu. Once you're there, you need to first publish your project. This will make it visible in the Snap website for everyone to see. And once it's published, you need to add it to the collection. So you just click on this button when Snap finishes loading the project, and select SnapCon 2021, which is probably going to be selected for you already because it's the last collection that was created. You click OK, and now your project should be in the front page. And there it is. So please do so. It'd be nice to have a nice collection of projects this year. Thank you everyone who showed their projects. There were amazing projects. I wish we could have seen more.